Welcome to Macmo Academy. In this video, we will understand functions and we will also see what are the types of the functions and how to represent a function and how to solve questions related to function. So first of all, let's write the definition of function. A function is a special type of relation. As we have already covered this topic, binary relation, in our previous video, and we will share the link of that video in the description for your reference. So we have done the relation over there. So over here we say that a function is a special type of relation, or in other words binary relation, in which every element of the domain, already we have done this thing, domain and range of domain, is associated with exactly one element of the codomain, with exactly one element of codomain. We will see this term as well, what is mean by codomain. We have already seen domain and range in our video related to binary relation, but we have not used this word codomain. We will see today in this video. So it is written, a function is a special type of relation in which every element of domain is associated with exactly one element of codomain. So here you need to understand one very important thing, and you can relate it with a practical life example. For example, here you can take this domain as an input and the element of codomain as an output. Now you are in your room and you are using the switchboard and you turn on the fan by using a switch or a button. So when you open a button, so your fan is turned on. So it is for one element of domain, means the button is the domain or the input and your fan is the output. So one input and one output, but it is written exactly one element of codomain, means exactly one output only for a particular input. If the condition is like this, that you are switching on a button and your light as well as fan is on due to only a single button, then this will not be considered as a function, because for one input there are two outputs. So this is not the case for the function, but it is a relation, because you are switching on the button and your fan and light as well as light, two things are opening from a single button. So it is a relation, they are connected with each other, but that will not be act as a function. So for a function, we will see the conditions of the functions as well, that for one input there should be only one output, and then for the other output there should any other input should be there. Okay, and we will see further conditions related to the function. So this is how we say that it is a function, that it is a special type of relation in which every element of domain is associated with exactly one element of codomain. Now how will you notate it? Notation, it is very important, that how to read it, how to write it. Usually we represent function by small f, but there could be any other alphabet as well. So we write it like this: function a to b, and here a is domain, inputs, set of inputs, and it is codomain. And it is not necessary that every element of codomain will be linked with domain. There could be some elements of codomain which will not be linked with the domain, or you can say in other words that there are some buttons, okay, and there are some appliances in your room, for example fan, light, or any other thing, and you are noting that there is no button for a particular object, means there is a holder or there is a light or there is a bulb and you are not able to open it with any of the button. So it means that that element is the part of the codomain, but it is not the output of any of the element of the domain, or in other words any of the input. So this is how we say that codomain are not necessarily the outputs, it is the possible outputs, but sometimes there are values of the codomain which are not the part of the outputs. So they are the possible outputs and they are all the inputs. So the actual outputs, there is thing actual outputs. So the actual outputs are called the range. So these words are important: domain, codomain and range. Sometimes students ignore this word codomain. They think that there is only domain and range, but remember, codomain is also very important thing in functions. Now we have discussed that what is mean by domain, the set of all the inputs. Codomain is the set of all the possible outputs, and range is the set of actual outputs. Now let's take an example. For example, we have a relation over here. As we have written that function is a special type of relation, so it means that all the functions are actually relations, but not all the relations are functions, because there are some conditions for the function. So let's understand. For example, there is a relation R and it is 1, 2, 2, 4 and 3, 6. So as we have already discussed that first elements of the ordered pairs are called the domain. Okay, so the domain over here is 1, 2, 3, and over here codomain is, let's say, range is, it is for range is 2, 4, 6. But if we talk about the codomain, so right now we see that the codomain is also 2, 4, 6, but it depends on the actual sets which are given. Maybe this particular relation is derived from these two sets. Set A is 1, 2, 3 and set B is 2, 4, 6, 8. So you can see over here in this relation 8 is not coming. It means that 8 is the part of the codomain. So for the codomain, we will write codomain is equals to 2, 4, 6, 8. So codomain are the possible outputs, but range is actually the actual outputs, and domain is all the set of all the inputs. So these are the important terminologies related to the function, that what is function, how to notate it or how to represent it, what is mean by domain, what is mean by codomain, and what is mean by range. Now we will see that what is mean by the conditions of function. Now when we say about conditions for a function, it is very simple, that there are two main conditions for a relation to be a function. As I said that not all the relations are functions, but every function is a relation. So if a particular relation is satisfying these two conditions, it will be counted in the family of a function. So for example, over here, the first condition is every element of the domain has an image. Every element, now understand it very carefully, every element of domain must have an image. Or an output. Now going back to that example of a switchboard and the appliances in the room. So for example, if there is a button in the switchboard and I am opening it and nothing is turning on, it means that there is an input but there is no output for it. So that will be not considered as a function. Every element must of domain means of inputs. Domain means inputs. Must have an image means output. If there is an input which is not having any output, for example, there is a machine and you are pushing or pressing a button and nothing is happening, means there is an input, there is a button which is considered as an input, but nothing is happening means there is no output for it, so it will not be considered as function, or you will say it is not functioning, it is not working. Okay, this is the first condition. So second condition is that every element has only one image of codomain, means every input must have output but must have only one output. For example, if you are or image, so for input we use the word domain, element of the domain, and for the output we use the word image. So now remember one thing, that as I have written in the first sentence, that every element must have an output, and one more thing which is connected to it, that every input or every element of the domain must have only one output. It should not be the case that I am pressing a button and two functions or two outputs are happening, or maybe I switch on, I press a button, I switch on the button, and the fan as well as the light is turned on due to one button. So that will not be counted as a function. So these two things are very important for to be a function. Now let's check an example. For example, we have a condition 1, 2, 1, 4, 2, 6. Now if you look at this, this is your input or domain, and these are your outputs or range. So you can see over here that this particular input has an output, this particular input has an output 1, 2. Okay, and this is also same input, but it is having another output, so it is repeating. So that is impossible for function. It is a relation, it is a binary relation, but it is not a function, as the input is repeated. So whenever you see in a relation that input is repeated, you will not consider that as a function. It is not a function, but you can take it as a relation only. Now one more thing that you need to understand, that for example, if we have set 1, 2 and we have 3, and I am writing a relation over here 2, 3, and I am not writing 1, 3, it means that this particular input is not having any output. So this will not be a function, because the input is not having any output, and it is written that every element of the domain must have an image or an output. Now, but one more thing that I will write over here, and you will think and tell me that will it be counted as a function or not. 1, 3, 2, 3. Now over here you can see that both the inputs are having output and the inputs are not repeating. So these two conditions are satisfying. It means that it is a function. So from here we can conclude that if the output is repeating, it is still considered as a function. So remember this thing, that repeating of outputs will not affect this particular condition. So it is a function, but there are some types of the functions in which we will see that the output is repeating or not, or output is left out. That is fine. But for a relation to be a function, only these two conditions must satisfy. There is no other thing. Remember this particular thing, everyone. Now after understanding that what is mean by a function and how a function is different from a relation, or what are the conditions for a relation to be a function, now we will understand that there are how many types and how we categorize the functions, or there are how many types of the functions, and how will we identify that this is this type of the function. So let's understand one by one. So if we have a function, if at least one element of codomain has no pre-image, and we will understand it by using mapping figure. Mapping figure means this type of figure is called mapping figure. This is for domain and this is for codomain. As we have discussed in our previous video, that the sets or the relations could be represented in sets form, could be represented in table form, and could be represented in this mapping diagram. So this one is more popular with respect to the functions, so that's why we will see this in the types of the functions. So if we have, for example, this condition that the domain are having elements 1, 2 and 3, and the codomain are having elements 2, 4, 6, 8. Now let's say that this input is having this output, this input is having this output, and this input is having this output. Now what left? You can see that in the codomain one element is left, but it is a function. If you remember the conditions that we have already discussed, that one input is having only one output. The output is repeated, that is fine. If it is repeated, right now it is not repeating, but if it is repeated, so that is fine. But input should not be repeated, and every input must have an image, and you can see that every input is having an image. But it is fine that if something is left in the codomain, that is fine. Right now the range is 2, 4, 6. Okay, and the inputs or the domain are 1, 2, 3, and the codomain are 2, 4, 6, 8. So whenever we have a function like this in which at least one element, it could be more than one element as well, which are left in the codomain, but if at least one element of codomain has no pre-image or has no input, it is called an into function. It is called an into function. Remember this name, because in the MCQs it will be asked like this or maybe in another way. So if you remember the definition of it or the condition of it, you will easily find out that which type of function is this. So remember that whenever we have an element in the codomain which is not having any input or which is not having any pre-image, at least one element, it could be more than one element as well. So this type of function is called into function. Now let's see any next type of the function. Now let's understand the second type of the function. Now for example, if we have a condition like this in which for exactly one input there is one unique output, or in other words, the output is not repeating. The output is not repeating. This particular type of function is called 1-1 function. 1-1 function, or there is one more name for it, it's called injective function. Why this is a type of the function? Because there is a condition which could be like this for the same function, that A is linked with 7 and B is also linked with 7. So in this one the output is repeating, but in 1-1 function you can remember it like this, that output will not repeat. If the output will not repeat, so it is a function, but it is not 1-1 function or injective function. So this is another type of the function. Now let's see the third type of the function. Now these are two more types of the function, third and fourth. So this onto surjective function means that nothing should be left in the codomain. Output could be repeated, but in the codomain nothing should be left, or you can say that codomain is equals to range, that every element of the codomain must be used as an output. Nothing should be left in the codomain. This is called an onto or surjective function. Okay, but if something is left, then that is into function. If you remember, we have discussed. And what is 1-1 function? Every input has unique output. Now if we have a condition in which there is a function in which, for example, we have 1, 2, 3, 4, P, Q, R, S. It is written a function is called bijective function, which is both 1-1 and onto. So 1-1 means that every input have unique output. And one more thing which you need to understand over here, that nothing should be left in the codomain. Nothing should be left in the codomain as well. So everyone have must unique output, and nothing should be left as well. So if something is left over here, it is called only 1-1 function, that every input has unique output. But if something is left over here, that will not be counted as onto, so it will not be counted as bijective. So these are the types of the functions, and in